This is my trigonometry course. Today we're going to learn the half-angle identities as well as more double-angle problems. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. In the previous class, we learned the double-angle formulas. There's three formulas for the cosine of a double angle. If we use this formula here, and we replace a with a over 2, and we simplify, then we come up with what we call the half-angle formula. This formula here is exactly the same formula that you see down here. It's just written in a different form. It's written in a different way. When you multiply the yellow a over 2 by 2, it cancels out the 2, and so we converted to cosine a. Over here we converted from sine a to sine a over 2. Now we're going to isolate sine a over 2 by subtracting 1 from both sides and dividing both sides by -2. Then we're going to square root both sides because we have sine squared a over 2. But before we do that, we'll rearrange these terms just to make them look nice and neat. When you square root both sides of an equation, you have to write a plus or minus symbol. And just to make the equation look neat, we're going to flip it around, and we see that sine a over 2 is equal to plus or minus root 1 minus cosine a over 2. So that is called a half-angle formula. The half-angle formula is the same formula that we see up here. Again, it's just written in a different form. You can do the same thing with one of the other double-angle formulas. Instead of 1 minus 2 sine squared, we have 2 cosine squared minus 1. And we come up with a half-angle formula for the cosine function. So we're going to learn how to use these half-angle formulas. These formulas are not as important as the double-angle formulas, but you will be expected to know them. In this class, we have to pay attention to the values of theta and theta over 2. So that's going to be the hardest part of the class. So it says if theta is in standard position and it terminates in quadrant 4, find the value of each expression below if cosine theta is 4/5. Now notice it says that theta is between 270 and 360 degrees in quadrant 4. The reason we have to say this is because there's a lot of angles that terminate in quadrant 4 that are not between 270 and 360. For example, this angle terminates in quadrant 4, but that angle is negative. It's not between 270 and 360. Also, we can go all the way around and around again and terminate in quadrant 4, but that angle measure is much bigger than 360 because it rotates a complete rotation and all the way around again. So that's why we have to specify that theta is between 270 and 360, or else we couldn't do this problem. So we're going to use our half-angle formula. We know cosine theta is 4/5. We're trying to find cosine theta over 2. We have a relation between cosine theta and cosine theta over 2. So our formula says that it's equal to 1 plus cosine theta over 2. Now, the first thing that we need to do, we need to determine if we're going to use a positive symbol or a negative symbol. So here's the part that's a little intimidating for students. If we know theta terminates in quadrant 4 and is between 270 and 360, as it tells us in the problem, then that means theta is obviously down here. So it's between 270 and 360. but we want to know where theta over 2 is. So we have to divide everything by 2. And when we do that, it moves everything to quadrant 2, and you'll see why. So if we take 270 and divide by 2, and take theta and divide by 2, let me give some more space here. And then we're going to divide 360 by 2. Then we have 135 degrees and 180 degrees. So theta over 2 has to be between 135 and 180, and you can see that that's going to be in the second quadrant. Now you're probably wondering, well, who cares? What's the point? Well, the point is, we now know that cosine theta must be negative. Not positive, it must be negative. Because cosine is always negative if theta over 2 is in the second quadrant, because cosine is this side divided by this side, the adjacent side divided by the hypotenuse. So the adjacent side must be over here, it must be negative. So that means cosine theta over 2 must be negative. So we have 1 plus cosine theta, and we know cosine theta is 4/5. So I want to make that clear again. We know that theta is between 270 and 360. They told us that. So theta over 2 must be between 135 and 180. And if theta over 2 is in the second quadrant, then that means cosine must be negative. Cosine theta over 2 must be negative, because this side is negative when theta over 2 is in the second quadrant. So we plugged in our cosine theta, and 1 plus 4/5 is 9/5. And we're going to reduce that to 9 over 10. Simplify the complex fraction to 9 over 10. And then we get negative root 9 over root 10, which is negative 3 over root 10. If we multiply both sides of the fraction by root 10, we get 3 root 10 over 10. And there you go. So that is how we can use the half-angle formulas to find the value of the trigonometric functions there. Okay, so let's go on to part 2 of this problem. We could use another half-angle identity, but we don't want to really deal with all of this type of math here, so it'd probably be best to simply use the Pythagorean theorem. So let me show you what I mean. If we have cosine theta over 2, then we can find all the other trigonometric ratios. We know theta over 2 terminates in the second quadrant. That's the green over here. So let's draw a hypothetical triangle. We know that cosine theta over 2 is negative 3 root 10 over 10. Negative 3 root 10 over 10. And by the way, this is theta over 2. And so now we can use the Pythagorean theorem to find the missing side. And then we get 100. And over here, negative 3 root 10 times negative 3 root 10 We can multiply -3 and -3 to get 9, and root 10 times root 10 is root 100. And square root of 100 is 10, so we end up with 90. So it may have been a while since we did some of this math, but that's how you would do that. Because we have the commutative rule of multiplication. So now we're going to subtract, and we get b is equal to plus or minus root 10. And is b going to be positive or negative? Well, we can see looking at the triangle that b has to be positive because that side is above the x-axis. So now let's write in root 10. And so sine theta over 2 is the opposite side of the triangle divided by the hypotenuse. And that's it, we're done. So now we're going to find tangent theta over 2. So we can use this triangle up here. Tangent theta over 2 is just the opposite side over the adjacent. So root 10 over -3 root 10. And the root 10s are going to cancel out, so we're left with -1/3. And there you go. So that's how you use the half angle formulas. Once you find the triangle that results from the angle theta over 2, then you can find the other ratios pretty easily, but we had to use the half angle formula in the first step. Okay, so let's try another problem before you try one on your own. Now our angle terminates in quadrant 2. If B is in standard position and terminates in quadrant 2, find the value of each expression below if we know cosine B equals -5/6. Now again, we have to specify that B is between 90 degrees and 180 degrees because it could be other numbers depending on if we're rotating more than 360 degrees or in a negative direction, so on and so forth. Okay, so we're going to use a half angle identity. So that is the half angle identity that we learned at the beginning of the class. And the first thing we need to do is figure out if we're going to use a plus symbol or a negative symbol. So we're told that B, whoops, that should be cosine B. We're told that cosine B, or B itself, terminates in the second quadrant. So that's over here. So what that means is that B has to be between 180 and 90 degrees. At least in this case, we're told that right from the beginning. And we want to know what quadrant B over 2 terminates in. Well, we just divide each of those numbers by 2. And we end up with 45 degrees and 90 degrees. So that's important information. We now know that B over 2 terminates in the first quadrant. So is sine going to be positive or negative in the first quadrant? And obviously it's going to be positive, so we're going to get rid of that plus or minus symbol and replace it. Well, we can just get rid of it completely because we know that this is going to be a positive expression. Sine is going to be positive in the first quadrant. So we know cosine B, we're given that information, it's -5/6. So I got that information from here. And now we need to recognize that that's a double angle, or it's, a double negative. We have 1 plus 5/6, and we get 11/6. And that simplifies to 11/12, and we get √11/√12. √12 simplifies to 2√3, and then we're going to multiply both sides by √3 to get √33/6, and there you go. So sine B/2 is √33/6. So we use the half angle formula again, and now we're going to find cosine B/2, but we have sine B, so we can find all the other ratios pretty easily. So instead of using another half angle formula, I'm just going to use this information here and the ratio that we found for sine B. So I'm going to draw a hypothetical triangle. We're told that the triangle terminates in quadrant 1. That's what we discovered over here. So this angle is B/2, and we know that sine B/2 is √33/6. So now we need to use the Pythagorean theorem to find the missing side. So we're going to get 3, or √3 that is, and we need to know if it's plus or minus, but you can see just by looking at the triangle it's going to be positive √3. If the triangles were over here, it would be negative √3. So we'll bring that up there, and now we can find cosine pretty easily. That's just the adjacent side of the red reference angle divided by the hypotenuse, and we're done. So it's pretty simple. So now let's find cosecant B/2. We know sine B/2 is √33/6, which allowed us to find this information here. But now that we have that triangle, we can just say that cosecant B/2 is the hypotenuse of that triangle divided by the side opposite. Notice that's just the reciprocal of this number here, because that's sine B. So then we multiply both sides of the fraction by √33, and we get the following. Then 6/33 simplifies to 2/11. And that's our answer, 2√33/11. So there's another example of a problem where we had to use the half angle formula to find a relation between the sine of a half angle and the cosine of B, a single angle, you could say. So I want you to take a picture of these formulas if you haven't already done that. And you can take a picture of this first problem and this second problem. And I want you to now try number 3. The first thing you have to do is figure out if your half angle is going to be a positive or a negative root 1 plus cosine alpha all over 2. And you're going to do that by looking at these numbers here and then dividing them by 2, and that'll tell you what quadrant alpha over 2 terminates in. So try number 3, and when you come back, we'll do it together. Okay, we're back. So cosine alpha over 2 is equal to plus or minus root 1 plus cosine alpha all over 2. Again, that's one of our half angle formulas you see up there at the left. Now we have to figure out if alpha over 2 is going to be, well, we don't know what quadrant it's in, so let's look at alpha. Alpha is in quadrant 3, so that's down here. We're told alpha is between 180 and 270. But if you divide those numbers by 2, divide alpha and all those other numbers by 2, we see that alpha over 2, well, let's write this down. So we're dividing everything by 2. And so alpha over 2 is between 135 degrees and 90 degrees. So that means that it's in the second quadrant. So is cosine positive or negative in the second quadrant? And the answer is it's negative. It's got to be negative because the triangle has, well, the side adjacent, the reference angle, has to be negative when the angle terminates in quadrant 2. So it's going to be negative root 1 plus cosine alpha. And we know cosine alpha is negative 1/3 because they told us that in the problem. We got that from up here. Again, these half angle formulas give us a relation between the single angle function and the half angle function. So 1 plus negative 1/3 is 2/3. And we simplify that, we get 2 over 6, which is 1/3. So we have negative root 1/3. And using our root rules, we root the numerator and the denominator, and we get 1 over root 3, multiply both sides of the fraction by root 3, and we get root 3 over 3, and that is our answer. So if you got that one right, excellent. So now let's find sine alpha over 2. Now that we know cosine alpha over 2, we can use that information to draw a triangle. We know that alpha over 2 terminates in the second quadrant. So let's draw a hypothetical triangle. And the sides are going to be, well, the hypotenuse is 3, and the adjacent side is going to be negative root 3. It should be negative because the triangle is in the second quadrant. So now we're going to use the Pythagorean theorem. So we have 3 squared is equal to b squared plus a squared. So we get 3 plus b squared is equal to 9. And do the math, and we find that have plus or minus root 6. But if you look at this triangle, is this side going to be positive or negative? Obviously it's going to be positive because it's above the x-axis, so we can write that number in there. And so now we can easily find sine alpha over 2. That's just the opposite side of the reference angle, and the reference angle will make yellow, I guess. So the opposite side divided by the hypotenuse, and we're done. So root 6 over 3. So if you got that right, excellent. So now we'll find secant alpha over 2. We can use that triangle up there. Secant alpha is the hypotenuse over the adjacent side. Multiply both sides by root 3, and we get 3 root 3 over 3. And the 3's cancel out. We're left with negative root 3. So if you got that right, good job. Okay, so let's try another one of these problems. I want you to go ahead and try number 4, and when you come back, we'll do it together. All right, we're back. So, we're going to use a half-angle formula. This time we're going to use a sine half-angle formula. And so we're going to have 1 minus cosine omega. And first thing we need to do is determine if we're going to use a positive symbol or a negative symbol. And to explain that, well, we know that omega is between 0 and 90 degrees, and if we divide omega by 2, then that'll tell us the possible numbers for omega over 2. We get 0 and 45 degrees. So omega over 2 has to be in the first quadrant. Obviously, we didn't really need to show that because it's pretty obvious when you divide, the numbers are going to be in the first quadrant still. So that means that sine has to be positive. So we can get rid of the negative, the plus or minus symbol, and cosine omega is 2/3. So 1 minus 2/3 is 1/3. And simplifying, we get root 1 over 6. And that's root 1 over root 6, which is 1 over root 6. Multiply both sides by root 6, we get root 6 over 6. And that's the answer for part 1. So you got that right. Excellent. So now we can use this information to find the value of all the other ratios. So let's draw a triangle. We know that omega over 2 terminates in the first quadrant. We know that sine omega over 2 is root 6 over 6. And this angle is going to be omega over 2. So now we can use the Pythagorean theorem to find the missing side. And so when we do the math, we come up with plus or minus root 30. And if you look at this side here, you see that it has to be positive because it's to the right of the y-axis. So let's put this in the triangle. And now we have everything we need to find the missing trigonometric values. Cosine is the adjacent side over the hypotenuse, and we're done with that part of the problem. Cotangent is the adjacent side of the triangle, this triangle up here, divided by the opposite side. And one tricky thing you can do here is we can change to this form here. That's just going backwards. We usually have something of this form, and then we change to root A over root B, but you can also go backwards if it's convenient. So I don't mean to confuse you with that, but you can also just multiply both sides by root 6, but you're going to get kind of big numbers if you do that. So we end up with root 5, and if you got that one right, excellent. Okay, so let's do this next problem together. So this problem is different because we're given the value of sine beta instead of cosine beta. We're going to use a half angle identity. And first thing we need to do is determine if we're going to use a plus sign or a negative sign. So we're told that beta is between 180 and 270. It terminates in quadrant 3. So that would be down there. So again, we know beta is between 180 and 270. And we want to know where beta over 2 is going to end up. And just doing the math, you can see what's going to happen. If we divide everything by 2, we get 90 degrees and 135 degrees. So that obviously puts beta over 2 in the second quadrant. So is sine positive or negative in the second quadrant? And the answer is it is positive, so we're going to keep the positive symbol. Now we're faced with another problem. We don't know the value of cosine. We know the value of sine beta, but not cosine beta. So we're told that beta, like I said, terminates in the third quadrant. So let's draw a hypothetical beta. And let's draw the relative side lengths. So the opposite side we can say is negative 2 root 6. And the hypotenuse is 5. And so let's use the Pythagorean theorem to find the missing side so we can find the value of cosine beta. So we have 5 squared is equal to b squared plus negative 2 root 6 squared. And so we get 25 over here, and negative 2 root 6 times negative 2 root 6. It's been a while since we did math like that, but you can multiply the negative 2's, and you get 4, and multiply the root 6's, and you get root 36. Root 36 is 6, so 4 times 6 is 24. And maybe I'll keep that over here in case anybody wants to review that. So subtract 24 from both sides, and we see b squared is equal to 1. And square root both sides, and we get 1. So is it going to be positive 1 or negative 1? Well, we see that this side is on the left, to the left of the y-axis, So it's going to be positive 1. Okay, so we can put that number up here. And now we can easily find sine beta. Sine beta is, cosine beta. Cosine beta is negative 1 over 5. So we have 1 plus 1/5, which is 6/5. And simplifying, we get 6 over 10. And that's going to be root 3 over 10. 3 over 5. And using our root rules, we get the following. Multiply both sides of the fraction by root 5, and we get root 15 over 5. So if you got that one right, excellent. We know the value of sine beta over 2. We know that beta over 2 terminates in the second quadrant. And we know that sine beta over 2 is root 15 over 5. So now we can use the Pythagorean theorem to find the missing side. And we get plus or minus root 10. And you can see that this side has to be negative just by looking at where the triangle is. So we can plug this in here. We have negative root 10. And now we can find cosine beta over 2. That's the side opposite the yellow reference angle. Or excuse me, the side adjacent the yellow reference angle divided by 5. Okay, so go ahead and take a picture of that problem. You're going to do a problem just like that. I want you to try number 6. And you're going to use a half angle formula, but you have sine theta, you don't have cosine theta. So you're going to have to find cosine theta using theta. And you're then going to have to determine if cosine theta over 2 is plus or minus root 1 plus cosine theta over 2. And so try number 6. If you get stuck, that's okay, but do your best, and when you come back, we'll try this problem together. Okay, we're back. So we're going to use our half angle formula. The first thing we need to figure out is, do we use a positive symbol or a negative symbol? And so let's look at theta. Theta is in quadrant 4. They tell us it's in quadrant 4. And it's between 360 degrees and 270 degrees. So we want to know where theta over 2 is going to be. And if you do the math, you can see it's actually going to end up in quadrant 2. We can divide theta by 2. And we get our new values, possible values for theta. So theta over 2 is between 180 degrees and 135 degrees. So that would be in quadrant 2. So that means the cosine theta over 2 is going to be negative, because cosine is always negative in the second quadrant. So we're going to write negative, and cosine theta, we actually don't know what that is. So now we have to take care of that problem. We know theta is in the fourth quadrant. So I'm going to draw a hypothetical theta and a hypothetical triangle. And we know sine theta is negative root 7 over 4. And so now we have to use the Pythagorean theorem to help us find the missing side. So we have 4 squared is equal to b squared plus a squared. And we get 7 here and 16 here. And therefore b is equal to plus or minus 3, but you can see that b has to be positive 3 because this side over here has to be positive. It's on the right of the y-axis. So now we know cosine is the side adjacent the yellow reference angle divided by the hypotenuse. So that would be 3/4. And so 1 plus 3/4 is 7/4. And then we reduce that, we get 7 over 8. And then we're going to square root both sides of that fraction using our square root rules. And we have a 2 root 2 is going to come out in the bottom. And then we're going to multiply both sides of the fraction by root 2, and we get root 14 over 2 times 2, which is 4. So if you want to review rationalizing denominators, you can go back to my intermediate algebra course or my beginning algebra course and review that. Whoops, I forgot the negative symbol. Sorry about that. We still have a negative symbol there. So I'm going to write that in. So if you got that right, good job. Now let's find sine theta over 2. We can use this information here. We know theta over 2 is in the second quadrant. So we can draw a hypothetical triangle. And we know that cosine theta over 2 is negative root 14 over 4. So now let's use the Pythagorean theorem to find the missing side. So we have 4 squared is equal to b squared plus a squared. And we get 14 plus b squared is equal to 16. And b is equal to plus or minus root 2. But you can see that b has to be positive root 2 because this side up here, you can see just by where the triangle is, it has to be positive. So now we're ready to find sine theta over 2. That's just the opposite side of the yellow reference angle divided by the hypotenuse. And there you go. We're done. So if you got that one right, perfect. Okay, so now we're going to go to some double angle problems. We learned the double angle formulas in the previous class, and we're going to do some other varieties of these problems. So you have an idea of how the half angle formulas work, but now we'll move on to double angle problems. So if B is in standard position and it terminates in quadrant 1, find the value of each expression below if sine B is equal to 1 over root 3. So this is just a type of problem that you'll get, and we're going to use the double angle formulas. So you can see we have 3 formulas for cosine, the cosine of a double angle. We're going to use this one here because we're given sine B. So 1 minus 2 sine squared B is equal to cosine 2B. And sine B is 1 over root 3. And all we have to do is simplify that. So 1 over root 3 times 1 over root 3 is 1 over 3. And then we have 1 minus 2/3, which is 1/3. And remember, with the double angle formulas, you don't have to worry about a plus and minus symbol. The sign is going to be taken care of in the double angle formula for you. So now we're going to find sine 2b, and it says we want to use this formula here. So we have to find cosine b before we do that. We have sine b, but we don't have cosine b. We're going to use our double angle formula, but we don't have this cosine b, so we have to find cosine b. Now we're told that b terminates in quadrant 1. So we can say that this is b, and sine b is 1 over root 3. And again, using the Pythagorean theorem, we can find the missing side. This is just one way to find sine 2b. And so if we simplify, we get plus or minus root 2. And is it going to be positive or negative? Obviously it's going to be positive because it goes there. That side is to the right of the y-axis. And now we can easily find cosine 2b. Now we already knew what sine b was. That was 1 over root 3. They gave us that in the problem. But now we can find cosine b, which is the adjacent side of the purple reference angle over the hypotenuse. So root 2 over root 3. And now we can multiply, so we get 2 root 2 over 3, and that's it. So now we're going to find sine 2b again, but we're going to use our value of cosine 2b that we found in the first part of the problem. So we know cosine 2b is 1/3, right? And we also know that b is between 0 and 90 degrees. So this is just a different way to do this. And so we're going to figure out what 2 times b is, or we're going to figure out the possible values for it. And it seems that 2b has to be between 0 and 180 degrees. But we know that cosine 2b is 1/3. That's positive 1/3. So it can't be in the second quadrant. It's got to be in the first quadrant. So now we can draw a hypothetical 2b. Again, we know it has to be in the first quadrant. And we know that cosine 2b is 1 over 3. So now we can use the Pythagorean theorem again to find the missing value, and we get plus or minus 2 root 2. And is this side going to be positive or negative? Well, obviously it's going to be positive because that side is above the x-axis. So b is equal to positive 2 root 2. So we can put that number here, 2 root 2. And now we can find sine 2b pretty easily, and we should get the same answer that we found up here. So sine 2b is the opposite side, 2 root 2 over the hypotenuse. And you can see that we got the same answer. So that just demonstrated two different ways to find sine 2b. We could use the double angle formula, or we could use the value of cosine 2b that we found earlier. Okay, so let's try another one of these problems. So now we have omega terminating in quadrant 3, and we have three different double angle formulas. We're given cosine omega, so this time we're going to use a different double angle formula. Cosine squared omega minus 1, 2 cosine squared omega minus 1. And we can just plug in the value of cosine omega that they gave us in this problem. We got that from there. And so we have 2 times 2 over 9 minus 1. And then we get 4 over 9 minus 1, which is negative 5 over 9. So remember, we don't have to worry about getting the wrong sign. When you're using the double angle formulas, the formula takes care of all that for you. Okay, so now we're going to find the value of sine 2 omega using the double angle formula, just like we did in the previous problem. Now they tell us that omega terminates in quadrant 3. So that's down here. That's omega. And they told us that cosine omega equals negative root 2 over 3. Negative root 2 over 3. And we're going to use this to find the value of sine omega, because we need sine omega to use this formula. We only have cosine omega. So now we're going to use the Pythagorean theorem to find the missing side. And we have 3 squared is equal to b squared plus negative root 2 squared. So we get 2 plus b squared is equal to 9, and b is equal to plus or minus root 7. And of course you can see that it's going to be minus root 7, negative root 7. So let's enter that, or write that next to the side there. So now we can find sine omega really easily. Sine omega is the side opposite the yellow reference angle divided by the hypotenuse. And cosine omega, we were given that value, negative root 2 over 3. So now we multiply and we get 2 root 14 over 9. So that is the value of sine 2 omega. But now we're going to use a different method we're going to use the value of cosine 2 omega to find the value of sine 2 omega. Remember, when you have one ratio, you can find the other 5. But we're told that omega is between 180 and 270 degrees. So we want to know where 2 times omega is going to be. That's going to be helpful to know that. So it's going to be between 360 and 540 degrees. So that means it's going to be in the first or second quadrants, because we're going to start here and go all the way around 360, and then we're going to keep going. That'd be 450 and then 540. So 2 omega is going to be between 360 and 540. So that's the again, the first and second quadrants. Now cosine 2 omega is negative. So that means it can't be in the first quadrant. It's got to be in the second quadrant. So I'm going to move that back a little bit and make a hypothetical triangle. And I'm going to label that. So the reference angle is the yellow angle. And cosine 2 omega is -5/9. So again, we're using cosine 2 omega. That's what's different about this. We're going to find the same value of sine 2 omega, but we're using cosine 2 omega, the value we found for cosine 2 omega, which is here. So now we need to use the Pythagorean theorem. So 9 squared is equal to b squared, which is equal to -5 squared, or plus -5 squared. So we have b is equal to 81 minus 25, which is 56. B squared is equal to 56, and b is equal to plus or minus root 56. And 4 times 14 is 56, so the 4 can come out as a 2, and the 14 will stay in. And we can see that that's going to be a positive number because that side of the triangle is above the x-axis. So now we can find sine 2b, or 2 omega that is. Using that triangle, it's going to be the opposite side of the yellow reference angle divided by the hypotenuse. And you can see that that value is the same value that we got here. So what we're doing is demonstrating that there's multiple ways to do this. So go ahead and get a picture of that. Okay, so I want you to get a picture of these double angle formulas. You're going to need those if you don't already have those in your notes. And I want you to try number 9, and when you come back, we'll do it together. Alright, we're back. So we're going to use this double angle formula. Why is that? Well, because we know sine beta, so we have to use that variation there. So we have 1 minus 2 times root 5 over 3 squared. And that's going to be 1 minus 2 times 5 over 9. And then we get 1 minus 10 over 9 is equal to -1/9. So we found the value of cosine 2 beta. So now we're going to find the value of sine 2 beta using the double angle formula for sine 2 beta. We have sine beta that we can plug in here, but we don't have cosine beta. So we're going to have to find cosine beta. We're told that beta terminates in the second quadrant. So we can draw a hypothetical triangle. We're told that sine beta is root 5 over 3, so we know those side lengths. So that is beta. Now, of course, we're going to use the Pythagorean theorem to help us find the missing side. We have 3 squared is equal to b squared, which is equal to a squared. And b is going to be equal to plus or minus 2. But you can see that it must be negative 2 because that side is to the left of the y-axis. So now we can easily find cosine beta. We know sine beta is root 5 over 3. And cosine beta is negative 2 over 3. And so we have negative 4 root 5 over 9. So if you got that answer, good. So now we're going to do the same thing, except we're going to use the value of cosine 2 beta that we found previously. And that should be a beta, not a b. Okay, so they tell us that beta terminates in the second quadrant. It's between 90 degrees and 180 degrees. So we're interested in 2 beta. So we're going to multiply everything by 2 to get a feel for where 2 beta would terminate. And we see that 2 beta is between 180 degrees and 360 degrees. So that means it's going to be in either the third quadrant or fourth quadrant. Now cosine 2 beta is negative, so it can't be in the fourth quadrant because cosine is positive in the fourth quadrant, so we know it's got to be in the third quadrant. So that is 2 beta, and we know cosine 2 beta is negative 1 over 9, and we know that because that was the first step. We found cosine 2 beta. So now we're going to use the Pythagorean theorem. So we have 9 squared is equal to b squared plus negative 1 squared. And we see that b is equal to plus or minus the square root of 80. Now 80 is 16 times 5. So 16 comes out as 4. And this number has to be negative. And the reason I know that is because I can see just by looking at the triangle that that side is below the x-axis. So negative 4 root 5. And now that we have all this information, we can easily find sine 2 beta. We're not going to use the double angle formula. We did that in the previous problem. we're just going to look at this triangle. Sine 2 beta is equal to the opposite side of the yellow reference angle divided by the hypotenuse. So you can see we got the same value that we did in the previous problem. We just used a different route. So if you got that answer, excellent. So now we have one more problem. Go ahead and try number 10, and when you come back, we'll do it together. All right, we're back. So we have cosine b, so we're going to use 2 cosine squared b minus 1. That's one of our double angle formulas. And we're going to plug in the value of cosine. And we get 4 over 5 when we square that. Now we get 8 over 5 minus 1, which is 3 over 5. So if you got that answer, excellent. So now we're going to find sine 2b using the double angle formula. We have cosine b that we can plug in here, but we don't have sine b. So let's find sine b. We know b is between 270 and 360, quadrant 4. So we'll draw a hypothetical triangle. And we're told that cosine b is 2 over root 5. So of course we're going to use the Pythagorean theorem to help us find the missing side. And we get 5 is equal to b squared plus 4. And that's going to be plus or minus 1. And we can see that b has to be negative 1 because it's going to go over here. That side is below the x-axis. So now we can easily find sine b. Sine b is the side opposite the yellow reference angle divided by root 5. And then cosine b is 2 over root 5. So we get negative 4 over 5. So if you got that answer, excellent. Okay, so now we're going to find sine 2b again, but we're just going to use the value of cosine 2b that we found previously. It's just a different method. So we know that b is between 270 and 360. So we want to know where 2b is going to be. So let's multiply everything by 2. Sorry, my pen is kind of malfunctioning a little bit there. So we know it's got to be between 540 degrees and 720 degrees. So if we draw that angle 2b, we're going to go all the way around to 360 and then 450 and then 540, and then we're going to either be in the third quadrant or the fourth quadrant. cosine is going to be positive. So that means that we have to go all the way to the fourth quadrant. We know it's either going to be here or here, but it can't be the third quadrant because, again, cosine 2b is positive. So we're going to go all the way to the fourth quadrant and draw a hypothetical triangle. And we know cosine 2b is 3 over 5. So this side's 3, this side's 5. So if we use the Pythagorean theorem, we can find the missing side. Sorry, my pen is kind of malfunctioning. And if we solve, we get plus or minus 4. And you know that 4 has to be negative because we can see just by looking at the triangle, this value has to be negative. So now, sine 2b is going to be the side opposite the yellow reference angle divided by the hypotenuse. And there you go. That's the same value that we got for the previous part. So if you got that right, excellent. So if you'd like to take screenshots of all the work that we did to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1 and number 2 and number 3 and number 4 and number 5, 6, 7, 8, 9, 10, and 11. But don't go before you get your homework. Let's take a look at the homework. Here's screenshot number 1 of the homework. And number 2. And number 3. 4. 5. And here's the answers. So be sure to get that homework done completely, correctly, neatly, and keep it in order in your binder. And remember, if you don't do the homework, there's no way you're going to learn the fluency you need to master this material. So get that homework done, and I'll look forward to seeing you in the next class.